So this lecture is the fourth lecture. This is going to be dependent majorly on the prism. What is the function of prism? Okay, and what possible subtopics we're going to prism? There are three mains: dispersive power, angular dispersive power, scattering, Vibgyor we know, problems related to Vibgyor or not general numerical one, but angle of minimum deviation, angle related to refractions, or angle of emergence also. Okay, so these three topics are going to be there. Dispersive power, what it is, that is going to be given in this lecture. Whatsoever the full complete lecture, I seem it is going to be completed before 2 hours, but if it is going so we're going to do SF, or the next lecture is going to be most important one. In the next lecture, we are going to discuss optical instruments. Okay, in optical instrument, we are going to discuss telescope, microscope. Microscope have two types, telescope have two types. In great detail, we are going to discuss about the telescope and microscope. Basically, from telescope, microscope, either compound microscope, either astronomical telescope, the magnifying power question or the magnifying power related numerical you are going to face, either in boards, either in JE, either in any entrance examination. Is this clear, everyone? Is this clear now? Good. So, as we know, first of all, what a prism is. Tell me. Okay, in general, how you can know till the prism, I mean, till now you know something that is a prism, right? Triangle. But in actual, that is not the third or the fourth picture in this. We have first picture, we have second, okay, we have third, and we have fourth. So in general, the prism is look like this. There is a full complete rectangular sheet. I mean, three rectangular sheets basically is going to be joined in this way. I mean, first rectangular sheet like this base, another rectangular sheet like this, and another rectangular sheet like this. So in this way, a hat, what do you call jhopdi in English? Hut or hat? What? Hat is wearing and hut, if I'm not wrong. HUT, right? Right now? Hut, HUT, or jhopdi. Yes, oh, good. So a hut like a shape. This particular shape is in actual, in general, is a prism. This one. Okay, we have three surfaces. With the three surfaces, the refraction is going to be two surfaces by this one surface and this another surface. So obviously, prism is a transparent material or a medium in which, or you can say an object or an instrument in which we are going to get the refraction twice. Clear? So it is a transparent medium bounded by refracting faces non-parallel to each other. They are not parallel to each other. The angle between refracting surfaces is called the refractive angle or angle of the prism A or prism angle. Is this clear? So in normal picturization, in normal books, we see that particular image of prism, but in general, the prism is not in this kind of shape. This is the fourth kind of shape. What is going on here? This angle of refraction, this particular angle in between the two surfaces, because the two surfaces is which one here? As you can see clearly, the one surface and the two surface. Okay, and they are not parallel to each other. Got it? In the previous class, in the refraction between two for the slab, that we understood. So what it is, here also we have a two surfaces, one surface and the another. Got it? What is the basic difference? The refraction in between prism or in between the normal glass slab. You can say in normal glass slab, the refracting surfaces, one surfaces, second surfaces are parallel to each other. Is this clear or not, everyone? Because that is very basic, and believe me, very basic answers are really hard to give. I asked this question twice, thrice when I take this interviews 3 months back. Okay, so most of the people don't know about it, even the teachers, as you can see. So that is very basic thing. So what a prism is? It is a transparent medium. Got it? It is a transparent medium bounded, transparent medium bounded by two refracting faces non-parallel to each other. The angle between refracting faces, whatever the refracting faces you are going to take, angle between both of that is known as, is called refracting angle or angle of prism A or prism angle. This is clear till now? Basic. Okay. So now this is the relation between angle of prism A. See, in this particular lecture, most of the things you are going to see direct. But these direct relation and these direct, you can say, concept are going to ask direct, without any, you can say, extra language, without any other third language and so and so. Okay, I can give you the whole soul theory also, but that is not required here. Where it is going to be required, I have already provided, and I am going to provide it in future as well. So, prism, I mean related in prism, relation between angle of prism A and refracted angle R1, R2. So simply, first of all, as we know, whenever any particular ray, this is your refracting surface 1, okay, this is your refracting surface 1, this is your refracting surface 2. So it is going to give you the refraction. Simple as that. And as we know, prism is what? It is a instrument which have a two refracting surfaces non-parallel to each other. And that particular angle between them is known as angle of prism. So that is nothing much, but simply it is a geometry. Till now we are going to discuss about geometry. There is no physics in this, but after that we are going to. So as you can see, this is your angle of incidence with the normal. This is your angle of reflection R1. And we can see directly the moment I can say normal. So normal is perpendicular to this particular refracting surface. Clear enough? So if it is perpendicular to refracting surface, so this particular angle is automatically 90 minus R1. It is R1. Clear? In a same sense, this particular angle R2 is basically this angle R2 is angle of refraction, angle of incidence, not refraction, basically angle of incidence, angle of angle of incidence for refracting surface 2. For refracting surface 2. Is this clear, everyone? Clear na this one? For refracting surface 2. Got it. So again, this is a normal. I draw for you guys. Wait a minute. This red color line is a normal. This red color line is a normal. So again, the angle obtained. Okay, I'll give it a name also. There are two look-alike or similar triangle. First is this A, B, C, and A, B, E. You can see. So now you can see in triangle ADE. That is very basic. In triangle ADE, angle D. Angle D is 90 minus R1. Similarly, angle E is 90 minus R2. And we know in any particular triangle, the sum of all the angles is 180 degrees. So that is basically going on there. Clear? Is this clear now? Sum of all the angles in triangle ADE is angle A. What happened to my writing today? This. In triangle ADE, which is this, angle A plus angle D plus angle E is going to be 180 degree. Angle A is angle A. I mean, it is given prior to any particular numerical. In general, it is 60 degree. Clear? If it is not 60 degree, if it is not equilateral triangle, or you can say equilateral triangle means all sides are equal, all angles are equal. So you cannot say it is 60 degree. It is mentioned in that particular question. So similarly, then angle A, angle D is what? 90 minus R1. Okay. Angle E is what? 90 minus R2. and that is equal to 180 degree. Automatically you can see that I'm not doing anything, we just doing till now, we are doing here geometry. Angle A equals to, okay wait, angle A minus of R1 plus R2 plus 180 degree equals to 180 degree. So this 180 cancel with each other, or you can do this in a reverse way also. You can subtract that. So this gives me angle A, which is prism angle, is nothing but the sum of R1 plus R2. And again notice this thing, angle R1 R2 is not in the triangle ADE. R1 is the angle of refraction from refracting surface 1, and R2 is the angle of incidence for refracting surface 2. So that is important equation number 1. Is this clear? We prove that equation number 1 in general using this. Is this clear, beta? You can say this is in general what? The proof of equation. The proof of equation number 1. Okay. Proof of equation 1. Is this clear now, everyone? Very easy, very simple. So angle A equals to R1 plus R2 in prism. Till now we are just doing the prism property. Nothing more we are doing. Okay. Moving ahead, angle of deviation. Now what is angle of deviation? First of all, that need to be defined at least, but direct. So if I mean that direct, I don't require. Angle of deviation, it is defined. It is defined. It is defined as the angle, or it is defined as the angle. It is defined as the angle deviated. The angle between. It is defined as the angle between the deviated ray, between the deviated rays due to double refraction. Okay, due to, you can say due to refraction of prism, due to refraction of prism. I mean due to refraction of prism and the natural incident ray. Because I write it down in between the deviated rays due to refraction of prism and the natural incident ray if prism is absent. What is happening in this? If prism is not okay. Okay, as you can see, very easy, very normal to understand this thing. If the prism is absent, or you can say if the prism is not present in this scenario, so this ray is going to be in this way directly. Clear? But due to this prism, the first refraction is going to be at this first refracting surfaces. Here it is going to be in this way, and then the second refraction is going to be in this way from the surface 2, from the surface 1, from the surface 2. Why should I take this? From the surface 1, from the surface 2, we can see the twice refraction. So as you can see directly, this is the you can say emergent ray, which is going to emerge, which is going to you can say pass on throughout the whole refraction, or you can say the whole this particular thing prism. And wait. Okay, so this particular angle, as we know, this is the incident ray if this is not going to be the present, this particular thing which is prism, and that is the total deviation. So you can say that in two ways. Angle which, or you can say angle of deviation is the angle between the incident ray and the emergent ray also. Incident ray, or you can say it is defined as the angle between the emergent ray and the straight line incident ray if the prism is not there, if the prism was absent. Clear? Clear na? Angle of emergent E is something else. That is very easy, known as angle of emergent. I don't think so. I need to give you the definition of that also. Or should I? Tell me. What is angle of emergent? Tell me, beta. Do you need definition? Do you need? No. Wait for a while. I am calling me right now. Wait, beta. This is. Hello. Yeah. So as you can see, E is angle of emergence. Now we need to find the again relation between I, E, A and this angle of deviation. And again this is the geometry as you can see. But it is, I am going to prove this equation number A. Right now, instead of saying 1, we can say A on the basis of geometry. How are we going to prove that? How many of you know that particular theorem? The external angle of a triangle is equal to the opposite two angle, sum of opposite two angle in a triangle. How many? You know this? Everyone? Oh, good. So there is a theorem in class 10. So what that particular theorem states that this particular angle of deviation, which is the external angle, again, this is your A, this is your B, this is your C, this is the D, this is the E, this one. Okay. So in triangle A, or I need to give us some name to this also, then P you can say. Okay. In triangle. Okay. So now in triangle PDE, this is the external angle. Okay, this is external angle made by this particular line or deviation. So this external angle, which is angle of deviation, is equal to the sum of two opposites. Now what are the sum of two opposites? This I minus R1 and E minus R2. Is this clear, everyone? Beta, is this clear or not? Clear na? Good. So that is I minus R1 plus E minus R2. So that is first case. And how so? Okay, I need to write here separately. Using a theorem, I just write this line. Okay. Using a geometrical theorem. Theorem of triangle. Theorem of triangles. Triangles. That is in triangles. That is in triangle P D E, angle of deviation okay, is equal to the this angle I minus R1, angle I minus R1 plus angle E minus R2. Or simply you can say that angle also removed, because then you are going to confuse. So that is angle of deviation, which is this I minus R1 plus E minus R2. Simple. Okay. So that is one piece. Now I minus R2 plus E minus R1, that is going to be 1. That is 1. Clear, everyone? So simply after this theorem, as you can see, we take minus sign common and separate it. I can write this thing in this way also. Angle of deviation is I plus E minus of R1 plus R2. And we know that R1 plus R2 angle A from the previous page, angle of prism is equal to R1 plus R2. So I can note it down in this way also. Clear? So again, this angle of prism is nothing but I plus E minus of angle. Again, proof of equation A. Small because capital A is angle of prism. Is this clear, everyone? Clear na? So this is we already proved. Clear, everyone? And this one is then I can remove and I can do. Is this clear, beta, everyone? Simple things we are doing till now. Okay. Once again, as we can see, this is the relation between angle of prism A and refracted angle, or you can say refracted angle R1 R2. So R1 is angle of refraction for first surface, R2 is angle of incidence for second surface, also known as angle of refraction because the second time refraction is going on. So in triangle ADE, we can do that angle A equals to R1 plus R2. In the same sense, angle of deviation, what is the angle of deviation? Angle of deviation, this, okay, or you can say angle of deviation, I can write it, angle of deviation, simply this is the symbol and this is your angle of deviation. Clear? So it is defined as the angle between the deviated rays due to refraction of prism and the natural incident ray if the prism, that is prism, M is missing, if the prism prism is not there. If the prism is not there. Is this clear, everyone? Till now. Again, I just use the what? Geometry. Nothing physics. Okay. Clear? Should I move ahead? Everyone? Good. This. Yeah. Now, angle of minimum deviation. So, what we are going to discuss? We are going to discuss this mean. Angle of deviation we understood. So, angle of minimum deviation we are going to find it down, and that is very easy. Using Snell's law, mu1 equals to sin I equals to mu2 equals to sin R1 for refracting surface 1. Okay. There is diagram or not? If it is not, so that is I am going to give you, and that is going to be easy understood for you guys. Okay, this is perfect. I note it down here. Just a minute. This is visible, right, everyone? So on this, as we can say, mu1 is this. I am not considering this air. I can take any particular medium, so I can make it mu1. That is mu2. Any other medium 2, and that is mu1 again. Clear na? So this is your refracting surface 1. This is my refracting surface 1, and this one is not good. This is my refracting surface 2. So mu1 sin I equals to mu2 sin R1. This is R1 for refracting surface 1. This is for refracting surface 1. For refracting surface 1. Clear? In the same sense, mu2 sin R2, which is angle of incidence here for the R2 surface, for this refracting surface 2, and mu1 again E. So that is for refracting surface 2. Is this clear everyone till now? Clear beta everyone? Now, condition of minimum deviation or minimum deviation. What is the minimum deviation? In this condition, I1 equals to I2 equals to I. Okay, I1, which is this particular I, is going to be I in general, and R1, R2 equals to R. Okay, what I am going to, one thing is missing. I is going to be needed this E, if I'm not wrong, because angle of deviation doesn't consider I in this. 2I. Here, one thing is, wait a minute. Okay, first of all, from the previous page, we know angle of deviation is I plus E minus of A. Clear everyone? Is this clear? That we find now in the previous page, angle of deviation is this. So in this condition, what particular condition we can get angle of minimum deviation? So this is going to be minimum when angle of incidence is equal to the angle of emergent, and R1 is going to be R2. Is this clear? So when angle of incidence in this condition, I1 equals to E equals to I, simply, okay, I1 this, and this E we are going to put simple I, angle of incidence, and R1 and R2 is going to R. This angle of refraction from the first surface brings angle of refraction from the second surface, or you can say angle of incidence for second surface is going to be equal. Since R1 plus R2 equals to A, so A equals to 2R, because R1 equals to R2, okay, and R1 plus R2 equals to A, so it is going to give you A equals to 2R, what is written overly directly, and then angle R, which is angle of refraction, is A by. Is this clear till now? Is this clear beta everyone? Is this clear now everyone? Clear? Okay. So till now we are talking about this. Now on the next page, the angle of minimum deviation is going to be then, I can put A equals to A by 2. I can do that using, okay, wait. Now angle of minimum deviation, I mean, or you can say delta mean, is going to be 2I minus A. I can use that where A is A by 2. Clear everyone? So this is my angle of minimum deviation. Clear beta? Using this I can find angle of incidence also and angle of refraction also. Angle of refraction we already know, R equals to A by 2, but if I want to find the angle of incidence, that is important. Okay, see, you can see that angle of minimum deviation or minimum deviation is simply minimum deviation, you can say that del min equals to 2I minus A by 2 directly, or you can put minus simple this small a. So this is first thing. Okay, second thing which is more important to this, angle of incidence for minimum deviation condition. How they can ask? They don't ask this directly thing. Angle of incidence. They means the numericals are formed in that way. Angle of, find the angle of incidence. EINCIDEN. For minimum deviation condition. For minimum deviation condition. For minimum deviation condition. So obviously minimum deviation condition is going to be the formula of the upper formula of this formula number, you can say 1 on this page. Clear? So using this particular formula number 1 on this page, what we can get, I in general 2I is L plus A by 2. Is this clear? Clear na? Or directly we can do that. Instead of A by 2, because it is going to be troublesome, I can write it down small a. Small a is automatically A by 2. Clear? And then angle of incidence I is going to be del of min plus A divided by whole 2. So we can find angle of incidence also. Already we know angle of refraction for minimum deviation condition is A by 2. That is everything I am talking right now, I am doing right now for the condition of minimum deviation. Clear everyone? Now if the prism is placed in air, or in general it is going to be placed in air, isn't it? In general it is going to be placed in air. So beta, you can see from this relation then, I mean this relation, or okay, I can make here for refracting surface 1, or okay, general condition, if, or in general, if prism is put it or placed in air, if prism is placed in air, then mu1 is going to be what? 1, or mu2 we can directly put mu. Clear na? Till now everything clear everyone? Then using Snell's law for first surface, surface at minimum deviation condition, Okay. So what is the minimum deviation condition? First of all, what is the Snell's law at first surface? If it is a triangle, or you can say if it is a prism, okay, it is a or prism, localized, not exactly. If it is a prism, so this is your angle of prism. Okay, here at the first surface, if I can draw the normal in this way, as you can see, this is your normal. This is again the normal. So wait a minute, this is your angle of incidence. Okay, this is angle of refraction. Okay, and then again this is the angle of emergence. So what we do till now, till this is your angle I, this is your angle R1, this is your angle R2, okay, and this one is your angle, not this one is the angle. Clear na? Clear picturization till now? So this is my refracting surface 1, this one, and this is my refracting surface 2. So at refracting surface 1, again that is air, so mu1 is going to be 1 for air, and for mu2 I can put mu directly. Alright. Refractive index. Alright. Clear? And that again mu1 equals to 1. So for using Snell's law for first surface is this surface. Very easy. Then after that, the same condition, the same equation we are going to write. As you can see, mu1 sin I. Clear? And main two things I am going to use. I am using here the Snell's law for first surface at minimum deviation. You need to focus on this also, at minimum deviation condition. So then, simple thing, mu1 which is 1, sine I directly. Okay, and mu2, which is mu sine R, because R1 R2 is R only. So we know R also. R is A by 2. Okay, and beta, this I, which is angle of incidence for minimum deviation condition, is del min plus A by 2 del min plus A by 2 divided by whole 2. Isn't it? Clear na? Till now. Okay. So then it looks like I'm teaching you maths today. So then I need to find this mu or refractive index for which particular condition, at which condition I am going to get the minimum deviation. Okay. So then this mu refractive index for minimum deviation condition, you can say refractive index of prism, refractive index of prism, refractive index of prism at minimum deviation condition. Mu sin I by sin R. We know the value of I also. We know the value of R also. Putting both the values, which is mu again at minimum deviation. At minimum deviation, which is mu, which is sin I. What is sin I? I mean, what is I? One thing, you cannot cancel 2 here because it is an angle. It is not directly something, and that is already given over there. Okay, A plus del min by 2, and that is sin A by 2. Is this clear, beta, everyone? Tell me, till now this is clear or not? Now I'm going to teach you physics on this. Till now I don't. Because till now we are doing geometry. Okay, so what is the benefit? What we are learning for this? Why we are learning for this? See, there are so many certain conditions in which you're going to bend the ray of light most, or you can say as much as you can. But maximum number of times we don't want to bend the light, we want to pass the light directly, or we want the minimum deviation. Or in this way, I can handle deviation according to my wish. Isn't it? See, just by putting this A, because everything I have in terms of A. Angle of refraction is A by 2. At minimum deviation condition, angle of incidence is also represented by A by 2. I got the refractive index also in terms of A by 2. So just by taking care of one parameter, which is angle of incidence, I can do anything on this condition. So that is why it is more important. And that is why it is not more, that is very, very important. Okay, so as you can see, that is the graph also. Angle of incidence I1 and I2. At this particular angle, where the angle of incidence is equal to angle of emergence, there is a graph. So that is going to be very less. As you can increase the angle of incidence I from 0 to this, there is going to be the angle of minimum deviation. What is that? The angle where angle of incidence is equal to the angle of second incidence, or you can say angle of emergence. Is this clear or not, everyone? Okay, it is more theoretically or numerical wise both important. Direct, whatever I tell you, whatever I am doing since last 40 minutes, they ask in one question. How they ask? First of all, this relation, you can say R equals to A by 2 and so and so. Or simply, they ask what is angle of deviation first. Give the formula in terms of angle of prism, which is A. And then, so first of all, you need to define and prove this. Okay, this is the relation A, you need to give. Then, at which particular condition, the prism is going to give you angle of minimum deviation. Then you need to define this everything. And then angle of minimum deviation, the relation between, or you can say the graph of angle of incidence with respect to angle of deviation, and show according to the graph at I equals to E, you're going to get the angle of minimum deviation or find the refractive index in terms of that. So last 3 slides directly they ask in 5-mark question. Or if they don't ask last 3, so last 2 slides along with numerical value. Or numerical on this is going to be asked so many times. Clear? The numerical, how they form numerical? The angle of minimum deviation for an angle of prism A, which is 40 degree. Okay, angle of minimum is given. Find the refractive index directly. Got it? Obviously, at that moment, most of the student doesn't know even about angle of deviation, what it is. So minimum angle of deviation and the condition related to that is a big thing. So this particular thing, or you can say this particular formula number 1 here, or you can say I already write it down, and the minimum deviation mu, formula number 2. No one remember that, or most of the students don't. Clear everyone? Clear na? Till now, if you have any doubt, question, query, so you can ask me. Is this clear? Good. Now, whatever we know, whatever we done till now, according to that, on the behalf of that, different properties we are going to find. So first is angle of minimum deviation. If angle of prism is A, small, less than 10 degrees. So we know that thing, there is a small angle approximation property. Okay, so many properties you need to use here. Small angle approximation. What is that? Small angle approximation. Small angle approximation states that sine theta is almost theta for theta equal and less than 10 degrees. Even less than. Okay. So if angle of prism is small, A less than 10 degrees, then sine theta is going to be theta. And then in this condition, this is my angle of minimum deviation. Clear na? Because A, which is going to be, sine theta is going to be directly theta. So what I am doing here, I just skip or eaten up one step. Sorry for that. Before this, as we know from the previous page, mu, which is sine A plus del minimum divided by 2 divided by sine A by 2. Okay. So this is what angle minimum deviation, refractive index at minimum deviation. Refractive index of prism at minimum deviation condition. Minimum deviation condition. So this is going to be my minimum angle of minimum deviation is going to be changed orderly automatically, and then this angle refractive index is going to. Is this clear? So this is again important. This one relation is very important. Angle of deviation, you can say minimum angle of deviation mu minus 1 into A for small angle of prism. Clear everyone? Nothing, just this small angle approximation for the Ri or on the previous formulas what we already done. Clear? Good. Moving ahead, deviation through a prism of small angle. So the deviation is going to be What is this deviation? So if angle of prism A is small, R1 plus R2 gives R1 plus R2 is A, and I and E will be small for the refraction at the surface AB. Okay, mu equals to sin I by this AB surface again. Mu equals to sin I by sin R1, and that is going to be, or mu equals to, or angle of deviation, this again going to be mu minus 1 minus of A. The above formula is valid for locations of the prism provided the angle of the prism A is small, less than 10 degrees. Okay, that is just written format what we already done. Deviation through a prism of small angles, as we know mu equals to I by R1, since I and R1 are small angles. So sin I1, okay, that is what, what it is written over there. Sin I1 is going to be I1 directly, and similarly sin R1 is going to be R1 directly using small angle approximation. For the refraction at the surface AC, mu equals to sin E by R2. Okay, because mu sin I, which is R2, mu equals to mu1, which is 1 at sin E. Okay, so that mu equals to E by R2, because E and R2 are small angles, so sine angle equals to, sine of E equals to E and sine of R2 equals to R2. So E equals to mu by R2, and then I, which is, angle of deviation, which is I plus E minus A, that is going to be I is mu R1, E is mu R2, so mu R1 plus mu R2 minus A, and in this way, that is going to be, this is basically the proof of angle of minimum deviation for mu minus 1 of A for small angle approximation. Okay, for a small angle approximation, approximation for a small angle approximation, minimum angle of deviation is nothing but minimum angle of deviation is nothing but mu minus 1. This is clear. We prove again here. Clear na everyone? Turn, open your cameras everyone. Is this clear or not? Clear everyone? Other than Yajira, there are another students also. Kyle, Netra, Parikshit, Sudarshan, Sai, and Yajira. Beta, is this clear to you? Kyle, Netra. Good. Okay. Do that then. Refractive angle of prism is given. Refractive index is given. What is the angle of incidence? I, to get minimum deviation. Do that. Very easy, very basic. Angle of minimum deviation you need to find. Do that. I'm not going to give you even a single % of hint in this, at least, because just above I let you know, guys. Okay, do this. Tell me the answer, beta. You are doing or not? Open your cameras. One minute, sir. Did anyone give answer? Sir, near 45 degree. Beta 45. 2 sine inverse 3 by 4. The proper answer is not given even in this, but pi by 3 and 3 by 4. I need to check, or you can check it out. Okay. In angle wise, I sine inverse 3 by 4. Yeah, I got I sine 3 by 4. Exactly. Somehow look like this. See, n is going to be 1, refractive index is going to be 1, simple. So for minimum deviation, R1 equals to R2 equals to, I mean R1 equals to R2 equals to RA by 2, that is 30 degree. Applying Snell's law at first surface, 1 into sine I, which is 3 by 2, into sine 30 degree, and I equals to sine 3 by, I mean that is equals to missing here. I can note it down for you guys. Angle of I equals to sine inverse 3 by 4. 3 by 4. Okay. And then angle of minimum deviation is 2 sine I minus A. Clear? Mu, or you can say angle of minimum deviation. I minus 2I minus A by 2, or A. A is pi by 2. Clear na? Is this clear, everyone? Wait, I do a little mistake somewhere there. Wait. I equals to A by 2. So here is going to be A, not A by 2. What are you guys doing? Not looking what I am writing. Here it is going to be A, and somewhere also I write A. Instead of small a, it is going to be capital A. Okay, and here as well. Instead of small a, you can put A. Simple. You don't need this. You don't need this. Okay, because simply we know angle of deviation is nothing but I plus E minus of R1 plus R2. That is angle of deviation. So R1 plus R2 is going to be A for minimum deviation, and I equals to E. Okay. Let me note it down this again. I equals to E, and this R1 equals to R2 equals to R equals to A by 2. This is the minimum deviation condition. So then I can write this as the A capital and then this as the 4 first. Clear everyone now? Here I do a small mistake. Here as well I need to write then A. Now everything is perfect. This one is done. Okay. So this is your angle. You can put it the values and write it down. Next question. Here you can see so many things you need to find. R1, R2, E and lambda for given diagram. Do that. Everything is given. I is given. Angle of prism is given. Mu is given. Got it? Simple question, this one. I can make it one or two with the just given examples, but I want you to guys find so many things. Then we can do one thing, do this question. We can take a break and then after that is very important thing, that is angular dispersion or Vibgyor or dispersion of light, and dispersive power, then scattering of light, this, and that. Okay. So R1 is 30 degrees, but I don't know R1 is what. You can do that. I'm going to take a break. I speak a lot. And 5 to 10 minutes break. You guys also take a break. After that, we are going to solve. Even you can solve in between. We can discuss, and then we are going to do the another concept. Clear? Hello, 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 hello. Am I audible? Am I visible, beta everyone? Just a minute. Give me a minute. Hmm. Everyone, try that, did that or not? How many of you are complete that? I mean, try, initiate. Very easy. For given diagram, you can say diffractive index is given. Ri is given for this particular surface 1, for this particular surface 2. A is given, I is given, R2 you can find, R1 you can find, right? Just a minute. R1 you can find, and the moment you can find R1, automatically you can find R2 without a doubt, isn't it? So this is your, a little lower I can do, because in this way, this is now your normal. So the moment you can find R1, automatically you can find R2. So this is your R1, this is your R2, and R1 is simply this 1 into sine 45, and root 2 into sine R1. Okay. So by Snell's law, using this Snell's law, sine 45 equals to root 2 sine R. R1 you can find in general 30 degree. We know that A equals to R1 plus R2, 75, 30, R2 is 45 degree. By Snell's law, at the emergent angle, we can find the emergent angle as well. Angle of E equals to 90 degree. Deviation also. Is this clear, everyone? Beta, is this clear or not, everyone? Sudarshan Sai Parikshit Kanetra Shri Trivikramanna. Beta, where were you since quite long? Your examination so and so what? Okay. So this is very easy, simple. Any one of the thing is going to be asked, and the minimum deviation condition maybe they ask from this also. For small angle approximation, minimum deviation is directly mu minus 1 into A. Here, automatically we can see that angle is not small. Okay. Now, this is for this one is for small angle approximation. Why should I tell you this right now? Just a minute, please. For small, small angle, for small angle approximation. If approximation, if this del min is given and A is given in this term 5 degree, okay, so you can wait, suppose x degree, okay, not 50, it is 5, it is 5 degree. So if A angle of prism is given A 5 degree and angle of minimum is given x degree. So with this small angle of approximation, we can find this mu directly. Clear? Okay. Next thing is very easy. We already know the basics thing. I'm going to let you know. After that, scattering. Wait. Okay, so now we are going to talk about dispersion of light, then angular dispersion, very easy. Then dispersive power of the medium of the material of a prism is, and then scattering. So it is going to be finished till 12, I think. So what is dispersion of light? The splitting of white color light into its 7 color component is known as dispersion of light. Is this clear, everyone? Vibgyor. It is going to be violet, indigo, camel, violet, indigo, blue, green, yellow, orange, red. That is the pattern. As you can see, red is going to be least deviated and violet is going to be most deviated. So simply what it is shows us the splitting of white light into its constituent colors in the sequence of behavior on passing through a prism is called dispersion of light. Simply. The refractive index of mu v is greater than mu r. What is the meaning of that? Tell me anyone. What is the physics and meaning of that? First of all, at least meaning. Physics I can tell you. Meaning of that is, tell me anyone. What do you understand from this mu v is greater than mu r? Why it happens so? Refractive index. I know better refractive index. But why? My question is why? Okay, simply, it is because wavelength of red color is greater. Exactly. That is the correct answer. As you can see in the previous lectures, refractive index, when I tell you what is the refractive index for any particular medium, simply C by V. Clear? C is the speed of light in an air and V is the speed of light in that particular medium. So here the medium is glass, or you can say prism. So we can take glass. So speed of light in air and speed of light in glass, Vg. Now we know one more thing also, C equals to lambda f. And I tell you that thing in a great detail in prism, or not sorry. In refraction, frequency is not changed. Frequency remains constant. So if frequency remains constant, beta, so what we can do, lambda in air, I can say, or vacuum, air I can write, because vacuum can be going to confuse you with V, violet. Lambda in air into frequency divided by lambda in glass for different colors. For this component, violet is going to be this, and frequency. So frequency this, and we know this lambda of, which is wavelength of violet, is least in visible light spectrum. Okay, in visible EM wave spectrum, we know this thing. The wavelength of violet color is least. Is this clear? Wavelength of violet is least, or you can say minimum. Least or minimum, and in the same way, this thing lambda lambda of red is going to be max or greatest. Okay, greatest, or you can say max. Okay, I need to divide it. Not divide, I need to remove it. V, right? Don't worry. Max means maximum. And that we know C is lambda into F remains constant. For what? For refraction. Clear? So as you can see, lambda R is greatest maximum and lambda V is least minimum. So automatically, refractive index we already know, that is mu is lambda on the basis of lambda air divided by lambda of any particular color. I'm going to write C. C is not there in this. Yeah, lambda of color. So due to this, the violet color have most, or you can say refractive index more for the same glass, for same thing, and this red color going to face, or going to feel the least refractive index for this reason. Okay, directly they can ask on what basis you can write this. Clear na? So on this basis we can write this. Obviously that much deep question in boards they don't ask, but if in any case they ask, so you need to know in a depth of this subtopic. Clear? And that is not even depth, that is already we taught teachers or tutors in class 10th even. For foundation level means for for little advanced version we teach this thing in 10th level. So therefore violet color deviates more Why so? Because it have the most refractive index, or you can say for this particular color we have refractive index more, so that is going to be deviate more. So direct question how they form, theoretical question, define what is the dispersion of light or dispersion of white light through prism, and why violet color deviates more. So when they ask violet color deviates more, obviously the first point we are going to write this. This is the first point. The refractive index of mu v is going to be greater than mu r. So if a 1 mark question, that is enough. But if a 3 mark question is this, so you need to explain that also. Mu, which is refractive index for any particular medium, single medium, whenever a ray of light is going to incidence from air or vacuum, so that is C by Vg. We can write it down C into lambda into F, and we know in refraction F, which is frequency, remains constant, so we can cancel out. So my refractive index is directly proportional to lambda, wavelength of color in a medium. Clear? And you need to explain that everything also. Got it, everyone? So obviously, if the violet color deviates more, or this red color deviates less, so the deviation angle for violet color is going to be the more in general property. Got it? And we can see that it is a white light. How can I draw white light? But okay, I think it is going to be visible, or if it is not, yeah, quite visible. Okay, so as you can see, if it is a white sunlight, assume that. So this is the refraction is going to be, and there is a breaking of 7 color components, and the red color, with the red color deviates less, and the violet color, this is my violet, it deviates. It deviates the most. What is the meaning of deviation? Everyone know. If this prism is not there, so this white light is passes through somewhere like this, isn't it? Or more clearly, somehow like this. So we can directly say that, we can directly see first of all that red have minimum deviation, and this violet have maximum deviation. Wow, what a beautiful picture I can draw on the given picture. Clear? So in reverse way, they can ask this one thing also. In the dispersion case, why angle of deviation for violet color is maximum, or in reverse also, so many ways, which particular color have a maximum deviation, angle of deviation, whenever a white light is passes through prism. So first of all, you need to know this dispersion of light concept. Second thing, you need to know which color is going to deviate more, and then the third, what is angle of deviation. Is this clear, everyone? These points, whatever I'm saying since last 2-3 minutes, it is clear or not? Okay. Or in comparison, if somehow sometimes you, to make a theoretical question moderate or complex, what the examiner can do, what we can do, tutors, match a column thing. Okay, and give you one theoretical concept, then give you 2-3 you can say points, and which one is the statement is correct, all the three, all two, or you can say none of them, every of them. Clear na? Means what I'm saying right now, in dispersion of white light, violet color deviates more, or red color deviates less. First statement. Okay, reverse of that, violet color deviates more, or violet color deviates less, and this red color deviates more. Second statement. Third statement, the angle of deviation is maximum for green and minimum for orange as compared to each other. Okay. Third statement, angle of deviation is maximum for red and minimum for this violet. Okay. And the fourth is none of them. Now the options are, each particular statement is correct, second statement is correct, third statement is correct, all the statement is correct. Okay, so then at that moment you need to know this everything, because obviously how you can say that particular statement is correct until unless you don't know this simple thing. Clear everyone? Clear na? In JEE means also, or in any other entrance exam also, you never ever, I mean, there is not a 100% probability that you get every particular question based on the numerical. In assertion region, they can ask this. Clear? First assertion is the deviation we in the dispersion of in the dispersion case, or you can say uh, in the dispersion the angle this in the dispersion violet color is going to be more deviate as sorry, violet color, indigo color is going to be more deviate as compared to the orange color. Reason is because the angle of deviation for orange color is high and the angle of deviation for indigo color is less. So both are true, assertion reason. Okay, or the reason is correct explanation. Assertion reason both are true, but reason is not a correct explanation. Assertion is correct, reason is false. Assertion is true, sorry, assertion is false, reason is correct. In this way, so many different kind of aspect or so many different kind of questions based only on purely theoretical knowledge we can form. Clear everyone? What I'm saying? Clear na? Okay, got it. Good. Now, angular dispersion. Angular dispersion is nothing but the angle theta, the angle substitute between the direction of emergent violet and red. This thing. I already make this. This one. This is your angular dispersion. Clear? Wait, I can draw. I can paste this diagram again. Copy paste him. Wait minute, beta. Hmm. 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 Clear? Hmm. More clear. So as we can see, what is the angular dispersion? Angular dispersion is nothing. The angle subtended between the direction of emergent violet, and red rays of a light from a prism is called angle of dispersion. Simple this angle. This angle is known as angular dispersion theta. Angular angular dispersion. Clear everyone? So as we know, angular dispersion is what? This. Again, this one thing. Just give me a minute. Angle of dispersion is what? This is my white light. If it is going to be passed in this way. Clear? And now I can choose which color? Green color. So this is my angle of deviation for red. And this is my angle of deviation for violet. Okay. Is this visible? Or this one is visible? This one is for violet and this one is for red. So I need to this angle only. So automatically it is very easy. Angle of deviation from violet minus angle of deviation for R. And we know that it is a small angle approximation because these angles are small. Na? This. So you can directly use this relation. Is this clear, beta, everyone? Because of small angle. Because of small angle approximation. We can what we can do? This angle of minimum deviation. angle of minimum deviation is nothing but mu minus 1 into. So 1 is going to be subtracted because mu v minus 1 into a minus minus plus it is going to be. Okay, you just put this formula with the help of color. So you can do that. Where del v and del y, this delta v and delta are the angle of deviation for violet color and red color. Clear? Is this clear, beta, everyone? Clear, na? Good. Next thing. Now this is the dispersive power. So what is the dispersive power? Dispersive power of the material medium is the property of a medium, how much it is going to deviate. Okay. For it is the property of the medium for a small angle, for a small prism angle less than this, with the light incident on a small angle I, mu v minus mu r, mu y is not given in, if mu y is not given in the question, mu minus 1 equals to refractivity of the medium corresponding to the text. Okay, y is basically yellow. Why we can take yellow? Because yellow is the deviation of mean ray. V big your, that is the in between. Okay, and when you can see with the proper numbering of wavelength, so automatically this yellow color have two mean 400 to 700 nanometer is the range. So the mean range is going to be 4 plus 7 divided by 2 in between, right? So 7, 4, 11 and divided by 2, which is 6 point something, 5.5. So the range of this particular yellow color is going to be approximate 550 or 544, 565 nanometer. But I'm saying, did you get anything? Tell me first of all. I'm speaking so many things right now. You are going to say, sir, going to be mad saying so many things. I don't get anything. This is the way. Tell me, beta. Okay, what I'm saying, vigor, or you can say visible spectrum. Visible spectrum is 400 to 700 nanometer. That is the range of wavelength range of visible spectrum. Clear? So if I want to find the mean, so del mean is in between somewhere. Basically it is going to be 400 and another value, but I don't know different values. So what I can do, initial point plus final point divided by 2. So in between median point we can get, so that is 1100 and that is 550 nm. And when we get the, when we find this yellow color wavelength, so it is automatically the mean ray. Okay, so that is why we put mu y. So basically dispersive power, how you can define it, is the property of a medium which gives you the ratio of you can say the deviation, or you can say which gives you the ratio. Basically in the last page what we can find, angular dispersion divided by the mean angular dispersion. Why should I say mean angular dispersion? Anyone? What is the meaning of this mean angular dispersion? This is your mean. Okay, let me define it properly. You guys seem so like I make you bored enough. Sometimes I do. This is my dispersive power. Okay, let me dispersive power. power, which is omega, which is angular dispersion, angular dispersion, angular dispersion divided by mean angular dispersion. Why should I say this? I mean, how I can write mean angular dispersion mu y minus 1. Let me explain you guys. Mean, mean angular, mean angular dispersion. See, angular dispersion you guys know, right? Angular dispersion AD I am going to write now. Angular dispersion, which is theta, you guys are know. Either you can write in terms of mu or angle of deviation, or either directly in this. So that is it's mu v minus mu r into a, and the mean angular dispersion is going to be mu violet, sorry, not violet, yellow, and refractive index of air. Refractive index of air or medium is 1. Clear na? Because mean, in between mean what we have? We have only and only this thing. What thing? Yellow color. Okay. So you can define this in two ways. Either angle of deviation or this what we find in this way. Difference of this angular dispersion basically, which is difference of deviation of angle violet minus red divided by the mean, and simply in one single sentence, dispersive power is nothing but the ratio of angular dispersion divided by the mean angular dispersion of any particular material of a prism. Clear? For a prism we are talking right now. Is this clear, beta, everyone? Tell me, is this clear or not? After that, the theory is going to be scattering and scattering properties. And, yeah. Is this clear, beta, everyone? Everyone other than Yajira. Is this clear to you? Kyle, Netra, Darshan, or this Shri Vikraman, and then Sudarshan and Pavan. Everyone clear na? Good. If it is clear, everything is just formulation and again representation for small angle. So for that is property of a medium. One thing for sure also, it is changed according to the medium. Why it is changed according to the medium? Because the moment you change medium, it is going to change. Okay. For small prism angle a less than or equal to 10 degree with light incident at a small angle I. So that everything we are going to put, theta is angular dispersion and del v, deviation of mean ray. Sorry, that is going to be y. Deviation of mean ray, which is yellow. So from here we can find the this refractive index of yellow, that is refractive index of violet plus refractive index of red divided by 2. And if you, if this refractive index of yellow is not given in the question, so mu minus 1 is the refractivity of the medium of the corresponding color. Okay, so that is simple. Now the next thing is theoretical one. Scattering. What is scattering is, you tell me. Because of scattering, the sky color have, the color of the sky we can see blue, and that is already done in class 10. So tell me, what do you guys know from scattering? Even after reading this, you can tell me. Just explain me what is written over here. Tell me, anyone. And please tell me with the help of your mic. I don't want to read your written messages or messages I'm saying. Written interactive thing. Speak up. I need to listen your voice. I think, I mean, you all are not speaking a single word. So I want to listen any one of your voice. Go ahead. Okay, do that. Here what it is written over there, the deflection of light energy by fine fragment of solid, liquid or gaseous matter from the main direction of the beam is known as scattering of light. The basic method involved with scattering is the absorption of light by the molecules followed by its re-radiation in different directions. The intensity of scattered light varies on the wavelength of light, the size of the particle. I mean, the scattered light varies on how it is going to be dependent on which factors of the factor that is written over here. The wavelength, the size of the particle causing scattering varying upon the size of the scattered of the following two situations. So two situations I'm going to tell you after this. But first, you tell me what is scattering. Go ahead. Tell me, beta. Anyone? Okay, give me two example of scattering of light. Real life example. And explain also. Give two real, two real life. Other than sky color blue. Two real life example of scattering. Scattering of light. What is this relay scattering? The relay scattering, sir, color of sun looks orange in the evening due to angle of incidence, and other times it will be blue or white. When you can see white, white is the color of cloud, not the sky. And sun, okay, you are talking about sun. So Rayleigh scattering, sir, color of sun looks orange in the evening due to angle of incidence, and other times it will be blue. Wrong. Sun doesn't look orange because of this. That is look orange because of atmospheric refraction, not because of the scattering. Got it? If anyone of you guys have doubt in this, so due to atmospheric refraction, the sunset and sun at the time of sunset and sunrise, you are seeing the this orangish color in the sky, or orange color of the sun even. Not due to this scattering. Any other? Anyone? And I say don't write it down here. I don't want to write your this long 2-3 line sentences. I want to listen. I want to hear your voice, to be honest. Anyone? See, that is very easy. Light due to a small hole in dark room. So how it is going to be related is scattering. Okay, tell me last time, I mean when you guys last time give some any oral examination? Viva or debate or stage performance or speech, or you can say any poetry, anything in front of your whole class. I'm not in front, I'm saying in front of whole school or section or teachers day. Okay. So why can't you speak here then? On teachers day, if you are representing this in your school in front of your class, so in front of 10 or 12 or 15 students, why can't you speak? Tell me. Today, sir. Yeah, today. What you ask today, beta? Light due to a small hole in dark room. I ask you how it is related to scattering of light, and you can say, today, okay. You give Viva today, then why can't you speak here to you also? I mean, I just genuinely wanted to know from you guys, what is the one thing uh, is the main obstacle whenever you ask something, and whenever I'm asking to you guys something, or you can say whenever you need to answer something, why can't you guys speak up? Am I listening properly? Suppose if I'm going to write everything, obviously I write a lot of things, but instead of saying or instead of uttering a word, I'm just writing everything. See, I say this line and this phrase so many times. Study is a two-way interaction process. Got it? And believe me, this is not my comment only. This is every tutor's comment for your batch. You are the least interactive batch we ever get. I'm saying we, not I. Least interactive. First of all, maximum number of students here turn off everything. Obviously, this pad you cannot turn it down. It is in our handle, but your cameras, your videos, your audios or any your videos. Audios are necessarily needed to be off. But if I am personally experienced on this right now and in the past also. And if someone also asks you something to speak up, I don't think so you speak up. So what is the one problem, one main obstacle you feel? Tell me. Suppose you are going for any particular interview. So everything you know are not going to write it down, na? Isn't it? Everyone here are going to face interview. Suppose you get any particular IIT. Suppose, according to your data, I can't say this, but I wish you guys are work hard enough and you get. Suppose the time you are going to enroll in any particular thing, there is an interview process out there. They wanted to check the verbally, the personality wise also, like in NDA, in CDS. Then you going to write everything on a paper. Like, sir, I am not capable or I am not interested in speaking, so I can do that. See, there is a obviously one you can say more thing is given to you guys to talk with us, to interact with us. This chatting, or you can say chat box, right? But suppose if it is not there, and you need to ask your doubt. So obviously you are not going to utter a word. I need to give you answer. Two real life example of a scattering of light is whenever a light is passed on through the small hole from a window or a room or any particular small hole. So we see the dust particle, very minute particles. Basically, these are the photons, light particles. So when light interact with a small minute dust particle, so we see a beam of light. So that particular beam of light basically scattering. Okay, one thing. Is this clear, everyone? And there is another thing whenever you in any particular mixture put a torch. Suppose there is a salt solution or there is a sugar solution. So you put you want to see that particular salt solution or sugar solution with the help of torch light. So you can able to see the minute particles and you can see the change in direction of the light ray due to this minute particle scattering. Clear? So simply scattering is the interaction of light particle, which is photons, with the very minute particle, with the particle which having the range of that photons or light wavelength, because light is made up of 7 color components. 400 nanometer to 700 nanometer. 700 nanometer, you can say 0.7 micrometer. So any particular particle of the range of micrometer, few micrometer, 1 micrometer, 0.5 micrometer, can interact with light. Because in white light, this, which is the wavelength of red, is 0.7 micrometer. So any particular particle of range 0.5 micrometer can interact with this, isn't it? Because the range is quite similar. Clear? So that is basically due to this scattering process, we are going to see so many different. So whenever we, through the small, from the branches of large tree in a jungle, so light is going to passes through small holes, or you can say this from the stems or from the branches. So the one or two or so many beams you can see. So that particular beam of light is because of scattering of light, because it is scattered whenever it is passed through small hole. So due to, in the process of passing through small hole, it interacts with the minute particle, dust particle, air particle of the order of its wavelength range. Clear? So that is that is the same thing written over here. The deflection of light energy. Deflection means it is going to deflect. Deflection of light energy by fine fragment of solid, liquid or gaseous matter from the main direction of the beam is known as scattering of light. And due to this, a atmospheric small dust particle, we are going to see the this blue color or mix of blue or violet, which is sky blue, because in our atmosphere the range of atmospheric dust particles or so and so are at the order of wavelength, which is violet or blue. Okay. The basic method involved in scattering is the absorption of light by the molecules, followed by its re-radiation in different directions. The intensity of the scattered light varies on the wavelength, and intensity is directly due to relay scattering something, lambda to the power 4. Okay. Or because relay scattering you guys don't get right now. Relay scattering. Wait. So intensity inversely proportional to the lambda power 4. Okay, not directly. So according to the relay scattering formula, the intensity of scattered light, I, is directly proportional to the 1 by lambda to the power 4. That is your relay scattering formula. Okay, so intensity of light is going to be this much. The size of the particle causing scattering, varying, scattering causing varying upon the size of the scatters of the following two situations arises. So due to this size of the particles which is going to scatter the light, two situations going to be happen. The first one is important one. If the scattering fragments, air molecules are of small size smaller than the wavelength of light, the intensity of the scattered light I fluctuates inversely as the fourth power of the wavelength of light. Okay, and that is known as Rayleigh scattering. Means if the particles of the order of 0.1 to 0.3 micrometer, because wavelength range of violet is 0.4 micrometer and wavelength of red is 0.7 micrometer. So then the intensity with this relay scattering formula is going to be I 1 upon lambda to the power. Clear? So that is your relay scattering formula. This declaration, which holds for elastic scattering, is known as the Rayleigh law of scattering. While the wavelength of the blue light is less than, that red light, blue light is scattered extremely white, the red, least blue color of sky, reddish color of sun during sunrise and sunset are due to this incident as discussed below. That is not correct. The sunrise and sunset due to atmospheric heat. Okay. Further, it is due to this because the red signals are managed to indicate danger. Such signals to go great distance without any significant loss of scattering. Why we make this red color as a danger sign? Because it is not scattered even for the large distances. It can visually easily from the few 2-3 kilometers. Scattering of light, the second important point. The second important point is if the scattering fragments are of size greater than the wavelength, means if particle size is greater than 0.8, or you can say in between 1 to 2 micrometer. Okay. So Rayleigh law of scattering is not valid and all colors are scattered equally. It is due to this the cause that clouds generally appear white. Is this clear? In a pear, we have a dust particle or you can say air particle or water droplets are the order of 1 to 2 micrometer. So because of this, the clouds appear white. Because the Rayleigh scattering phenomenon is not going to be there and any particular specific color is not going to be visualized. Clear now? Now this one is your question. Do that. A prism refractive index has a refractive angle. The deviation of a monochromatic ray incident normally is on one surface will be sine 48 36. What does it mean? 48 degree 36 minutes. Sorry. So what you need to do? You need to find angle of emergence. Angle of emergence you need to find and one more hint I can give it to you. Hint. As you can see, when you can read this twice, a prism mu is refractive index, refractive angle of this 30 degree. The deviation of a monochromatic ray incident normally on its surface, on its one surface. This is my prism. Just a minute. Give it to me. Okay. And that is your 30 degree. Okay. If I draw, this is my normal. So on the one surface, the deviation of more, so the light incident is normally. Okay, I can draw the normal light. So something this kind of scenario is happening. Clear enough, everyone? Something this relation is happen. Now you here need to find the solution. Option A is I need to change. Option A. Yes, but option A is correct. Everyone get option A? Sir, I'm not getting answer, sir. What is the problem? You are, you're not understanding this question. Did not get the what questioner wants to ask, or what the thing? No, sir. Some calculation. Calculation error. Very easy. 48.36. 0.75. So sine inverse 0.75 is going to be there then. Oh, sorry. Easy one. For surface AC. For surface AC 1 upon mu, what is that? This sine I by sine R is mu 2 by mu 1. Here mu 2 is 1 because of air, mu 1 is mu because of medium. I here is this angle, okay, given directly 30 degree. You can find it down, and this what it is, E, angle E we need to find, which is angle of emergence. So if I subtract minimal angle of emergence minus this angle of incidence, okay, so this is you need to do, and that is why 75, or you can say sine 0.75 is given. So you can do that directly, theta, which is sine inverse. I mean, that is why sine 48 degree 36 minute is going to given 0.75. So sine inverse 0.75 is 48 degree 36 minute. Is this clear, everyone? Is this clear now, beta, everyone? Easy one. Okay, next one is when light rays are incident on a prism at an angle of this deviation, the minimum deviation is obtained if the refractive index of the material of the prism is root 2, then the angle of prism will be. You need to find angle of prism. Very easy. Okay. Refractive index is given and everything. Tell me the correct answer. Tell me the correct answer of this, beta. Hey, everyone. Hmm. 30. But how I can get 60? Okay, let me check then. Sine A by 2. Beta. Half equals to sine A by 2. Okay. Wait. Sine inverse A is 60, not 50. Sorry, 30. Easy this one, beta. Okay, see. This is going to be for minimum deviation, right? This relation mu A plus lambda m by 2 divided by sin A by 2, and A plus lambda m by 2 is going to be I, which is 45 degree. It is given already. Angle of incidence, light incidence, yeah. Clear? And refractive index is given also. Perfect. So put it there. Sin 45 degree, sin A by 2 directly. Now we know sin 45 degree is 1 by root 2 into 1 by root 2. So from here, sin A by 2 is half equals to sin 30 degree. Then A by 2 equals to 30 degree. Then A equals to 60. See, on last moment, maximum number of students do the wrong thing or numerical mistake. Is this clear? That is why A is not correct answer. The correct answer is D, 30 degree. Sorry, 60 degree. So we are done for the lecture today. All over the lecture is dedicated to the prism. We are understand what prism is, refraction through prism, how we going to find it down, angle of minimum deviation, dispersion and dispersive power. So that we already done.